Hey, hello, welcome to today's GFG problem. Today we'll be doing well. So let's see today's problem, trapping rainwater. Okay. So what the problem is saying is we'll be given an array which will contain the height of each block. Okay. So for example, here three, right? So three means that there will be a block of size 3. Okay, of size 3. For example here, right? So there is this block 1 2 3 size 3, right? Similarly 0, there's no block here. Then we have 1 here, size block of size 1. Then again we have 0. Then we have 4 here, and then 0 and 2. Okay, so what the problem is saying is we want to find out how much water can be trapped between these blocks. Okay, so if we fill water, right? If we fill water, so how much water will be trapped here? For example, in this you can see, right? So here the water, whatever is the maximum on the left side, right? Whatever is the maximum on the left side and on the right side and on the right side. Okay, whatever is the minimum out of the heights of the both left side and right side of both left and right side, that much water can be filled. So what is that? So for example, here the size is 3, here the size is 4. Which is minimum? Minimum is 3. So the maximum water which can be filled is will be this level. Okay, so let's calculate here what is the maximum water that can be trapped. So here for example, definitely it's 3 here, so there'll be, we cannot store water over here. But here, right, here how much water can be stored? The water can be stored, okay, of unit will be 3. So for example, here let me write here. So here 3 units of water can be stored. And then for what, how much water can be stored here? So we already have one block here, so 2 and 3, right? That is plus 2. Okay, plus 2, plus 2. Here again the block size is 0, so the water that can be stored here is again plus 3, right? Plus 3. Okay, 3 units of water. Okay, and then here definitely no water cannot be stored here, but here the water can be stored. So whatever is the minimum on the left side and the right side? Right side is, what is the minimum height of the block? It is 2, right? Right? So here we'll take the minimum. So here the water which can be stored is 2 units, right? So plus 2 we'll say. So what is that? How much is that? It is 10, right? It is 10. So 10 units of water can be stored in this in these blocks. Okay, between these blocks. Okay, so that's what the problem is. Now how can you solve this problem? So due to the time constraint, I'm going to solve or explain the expected approach directly. Okay, today we won't see the naive approach. Okay, so yes, so what we're going to do here is, for example, let me write the problem here again. Let me write the array once here. Okay, 3 0 1 0 4 0 and 2. So this is our array. So what we are going to do is we are going to use the property only. For example, the left max and the right max, right? Left max and the right max. What is that? Left max and the right max. Here it is 3, here it is 4. And whichever is the minimum, okay, we are going to use this property. So for this, we are going to solve the problem using 2 pointers. So we are going to have one left pointer and we are going to have one right pointer. And we'll have two variables, left max, which will be 0, which denotes the maximum on the left side, right? Left max. And we have another right max. Right max, which will be 0 again. Okay. Again. Okay. Now what we are going to do here is, okay, what we're going to do here is, now we are going to check if if r of L, if r of L is less than. So we are going to run a while loop, wherein the while loop will have the condition left should be less than r. Okay, and then we're going to enter into the while loop and we're going to check here. If r of left is less than r of r, is it? No, it is not. It is not. So what is minimum? R of r is minimum. This is minimum, right? This is minimum. Okay. So what we're going to do here is we are going to check. We are going to check here if right max, okay, if right max is less than equal to, if right max is less than equal to r of r. Is it the case? R of r, right? Yes, it is the case. Right max is what? 0. And r of r is what? 2. Okay. So right max is less, if right max is less than equal to r, so we are going to, what we are going to do in this case, we are going to assign r of r to right max, which is 2. Okay, which is 2. Okay, so right max holds 2. Okay, now what we are going to do, we are going to decrement our r pointer. Okay, we are going to decrement our r pointer. Okay, now again we are going to check, is r of left, is it less than r of r? No, it is not. It is not. It is not. So again, what we are going to do here is we are going to check again. Right max, we are going to compare right max. Is it less than air of R. So what is right max here? Right max is 2. You know, right? Right max is 2. And what is air of R? It is 0. So no, this condition violates. This condition violates. So what we are going to do here is we are going to we are going to take another variable, the resultant variable, which is water trapped. Okay. Let me write it here. Water trapped equal to, it will initially be 0. Okay, water trapped will initially be 0. Okay, so what we're going to do, since right max is not less than equal to R of R, so we can store water. That means we can store water. So here is the case. So right max is here 2, and here R of R is 0, right? R of R is 0. So here is the case. So we can store water here. How much water we can store here? This much water we can store, which is right max, So what we're going to simply do, water trapped plus equal to water trap plus equal to right max minus air of R. Okay. For example, so what is the formula? That water trapped plus equal to right max minus air of R. Okay. So what is right max? What is right max? Right max is 2. And what is air of R? It is 0. Okay. 2 minus 0, which is 2. So what we are saying here is we can store 2 units of water. Here in this position, we can store 2 units of water. So we are going to update our water trap to 2. Okay. So why we are doing this? Right max. What is the right max? Right max is 2. Right max is 2. And what is air of R? Which is 0. So how much water? We can store this much water only, right? This much water only. So whatever is the right max, minus 2. Minus air of R, which is 0. Okay. For example, if this was the case, here, let's say right max was 3, right? And you had an air of R is this. Air of R is this. This is R, right? Now, and let's say this is another, this block, right? 1, 2, 3, and 4. Okay. Now we are here. Our air of R is here. So how much water we can store here? We can store how much water? We can store this much water, right? So what we are going to do, according to this formula, right max minus, what is right max? Right max is 3, right? Right max is 3 minus air of R. What is air of R? It is 1. One block of this is, the height is 1. So what are we going to do? 3 minus 1, which we can say 2. So how much water we can store? 2 blocks of water, right? Yeah, right? 2 blocks of water. That's what this answer is. And that's what this formula is. Okay. And that is why our water trapped answer is 2 for now. Okay. Let me quickly erase this. Okay. So now again, we are going to decrement our R. Okay. We are going to decrement our R. Okay. So our R will point here. Okay. Now again, we will check here. Is R of L less than R of R? Yes, it is. It is. And we're going to check again. Is left max, sorry, is left max, okay, is left max if it is less than equal to R of L? Is it the case? Left max initially is 0. R of L. R of L is 3. Yes, so left max, definitely this condition matches. It is less than equal to 0. It is less than equal to R of L. So we're going to just update the left max, which is 3. Okay, which is 3. Now we are going to increment our L as well. So L. Now again, we're going to check. Is R of L less than R of R? Is R of L less than R of R? Yes, it is. Yes, it is. So what are we going to do? Again, we're going to check here. This condition. Is left max less than equal to R of L? Left max now it is 3 and R of L is 0. So this condition violates. So we are going to use the other formula. What it is going to be? Water trapped plus equal to left max minus R of L. Okay. So what is left max here? What is left max here? It is 3, right? Left max is 3. What is left max? Left max is 3. Minus R of L is 0. R of L is 0. So how much water we can store? We can store 3 units of water. So we are going to increment 3 into water trapped. To 2 plus 3 equal to 5. 5. Now water trap will hold 5. Yeah, I hope you're getting. So simple, what we did here is simple. Let me try to explain here again. So so for example, here it was a block, right? The block of size 3. And here it was 0. There was no block. So how much water can be stored here? How much water can be stored here? So left max, which is 3, right? Which is 3 minus R of L, right? R of L, which is 0. So 3 units of water can be stored here because 1, 2, and 3. That's what, right? 1, 2, and 3. 3 units of water can be stored here. and hence this formula. Okay. So now what we are going to do, we have done here, we are going to increment our L. Now again, we are going to compare, is R of L less than R of R? Yes, it is. Yes, it is. So what are we going to do? We are going to check here again. Is left max less than, left max is, which is 3, less than equal to R of L, which is 1. No, it is not. This condition violates. So again, we are going to use a formula, water trap plus equal to, what is left max? 3. What is R of L? It is 1. So it is 2. 2, right? So we are going to update. We are going to add 2 to the water trap, which will be 7 now. Okay. I hope you're getting. Now, so again, this condition is this, right? What was this? This was our left max. This was 0. And this was one a block, right? A block of size 1, right? And how much water we want to calculate, how much water can be stored here. So it is going to be what? Left max is 3. So how much water can be stored? Till this much, right? Which is 1 and 2. 2 units of water can be stored. That is why 3 minus 1, 2. And hence we have updated our answer. Okay. Okay. Now again, we are done here. So we increment our L. We can check L. Definitely this is less than this. And again, this condition it is going to be violated because 3, right? Left max is 3 less than equal to R of L, which is 0, right? Which is 0. Okay. And then what we're going to do, we are going to use this formula, left max equal to 3 minus R of L is 0, which is 3. Okay. So we are going to add 3 to the already calculated water trap, which will be 10. Okay. And we'll increment our left pointer, which will point here left. Now left and R both are pointing at the same position. So we're going to break the while loop. Okay. So this is the intuition behind solving the problem. Okay. So I'll just request you please subscribe to the channel, like the video. Let's go and code. I think you'll understand better. Okay. I've tried to make it very easy for you. So definitely the difficulty level is hard, but it is not very hard. Okay. So let's quickly, let me write L equal to 0 and R equal to R dot length minus 1. Then left max, let's name it this left max, or maybe let's name it complete. Okay, left max equal to 0. Okay. Right max equal to 0 in water trap equal to 0, right? In water trap equal to 0. Okay. Now what are we going to do? While left or L is less than R, right? This is the while loop. Now we're going to check here. Is R of L less than R of R? Yes, it is. And again, we're going to check here, is left max. Sorry, my bad. So I'm showing the Java code followed by C++. Okay. So left max is less than equal to R of L. If it is, then update our left max. Okay. Update our left max with R of L. Okay. Else, use this formula to calculate the water trap. So definitely there will be some water trapped. Okay. So what the formula will be, left max minus R of L. Okay. Again here, I'm going to check here, is right max less than equal to R of R? If it is, then we need to calculate, we have found a bigger block. Okay. So we should updating our right max. Okay. If right max is bigger, right, then water can be trapped. So we will plus equal to right max minus R of R. Okay. That's it. Okay. So one more thing we just forgot. After this, for example, we have to increment our left pointer, and here we want to decrement the right pointer. Okay. And simply want to return water trapped. Okay. Let me compile this. We'll also discuss the time complexity. Okay. Let's submit it. Please don't forget to subscribe to the channel. What will be the time complexity here? It is going to be O of n because we are just having a while loop. Okay. And we are iterating the array only once. Okay. And what will be the space complexity? It is going to be O of 1. No extra space we have used. Okay. That is why O of 1. Okay. Thanks for watching. Please don't forget to subscribe to the channel. Like the video. Let's quickly see the C++ code as well. So not much difference here. Okay. This is exact code. Only difference is here it is size, there it was length. Okay. That's it. There's no much difference. So I'll attach this code into the description section. Thanks for watching. Please subscribe to the channel, like the video. I wish you a very happy, healthy, wealthy, and a great day. Thank you so much.